Yes, let's start. Today we will consider again and the second order differential equation and but homogeneous because right hand side 0 here is okay 0, and how to solve the any differential equation if first order sorry not first order second order differential equation, and but be careful and the coefficients constant coefficients. It's okay with constant coefficient, so we know how to find the solution of and our the given equation is in this form. It's okay with constant coefficient second order homogeneous differential equation. Write the corresponding and characteristic equation and this one characteristic equation. So this equation is the second r square. So we and these and the characteristic equation two roots has two roots. If and we have three case, first case, and these roots real and different and roots. So and for example, this one is and these roots are one and are two. It's okay, and the real numbers and also different roots. It's okay. So we know that and the fundamental and we have two and the corresponding and the fundamental solutions of our differential equation e to the r1t and e to the r2t fundamental solution, because Wronski indeterminate w is not zero. It's okay, fundamental solutions. So, and the right general solution, we know that general solution is a linear combination of y sub 1 and y sub 2. It's okay. And so general solution y is c1 y sub 1, c2 y sub 2. And this one is the general solution of the homogeneous differential equation. Yes, it's okay. So, and the second case, maybe our roots, the characteristic equation has complex roots. It's okay, and complex conjugates. Let's consider these case. It's okay, this case. If the r and the characteristic equation has this form, what's the form? R minus lambda square, r minus lambda square plus mu square. Lambda and mu real numbers, constants. So, and solve for r here, and so we obtain two roots. R1 is lambda plus I mu, and r sub 2 is lambda minus I mu, and here and the R1 and R2 are complex conjugate roots, because in this one is plus, this one is minus. It's okay, complex conjugates. So what can you say about the solutions, fundamental solutions? And each of them gives fundamental solutions. It's okay. And the R1, what's the, and we know that and the previous and the lecture, if and the R characteristic polynomial has two rows, R1 and R2, it's okay. And the corresponding solutions e to the R1t, e to the R sub 2t. It's okay. And here and this one is the first root. So and the y sub 1 and means first fundamental solution e to the r1t. Substitute here r1 and we obtain e to the lambda t times e to the I mu t. It's okay. And also we know and this one from calculus or okay. And what's the this one? This one is cosine mu t plus I sine mu t. It's okay. This one. And we obtain this one, and if here mu is not zero, it's okay. And because mu is zero, right, mu is zero, and then we obtain real number. It's okay. But here we will we consider here if our roots complex numbers, so mu should be non-zero. It's okay. Sorry, mu non-zero. So mu non-zero means and there exists the e to the and here I mu t, and then rewrite this one. This one is cosine mu t plus I sine mu t. And second roots of the characteristic equation r sub 2, and it gives the second fundamental solution, this one. And the substitute here r sub 2 t and substitute r sub 2 here, and then we obtain this one. It's okay, this one. So we have y sub 1 and y sub 2 here. It's okay. And here it's okay if y is u plus iv, it's okay, is a solution of our equation. It's okay, second order differential equation. And then what does it mean if this one is a solution of our equation means, and the substitute here our differential equation, this one gives to 0. It's okay, gives 0. So substitute here L of u iv, and we know that L is a linear operator from first uh, lecture about differential equation. We know that, and the second order differential equation, and L is a linear operator. L of y is this one. It's okay, and this y is a solution, and substitute y here, and L of u plus iv is equal, and linear operator, and also it's okay because the target and source space same, and L is a linear operator and linear transformation, and then it is possible to write in this form and separate L of u plus I L of v, because I is a scalar. It's okay, and so is this one is 0. This one is 0, and this plus I times this one is 0, and means this part should be 0 and this part should be 0. It's okay. So we obtain L of u is 0, L of v is 0. And what's the u here? It's okay, u. Look at the r and here, this one. And the u is real parts of y. It's okay. And what's the v? V is the coefficient of I, and this one. It's okay. So, and what does it mean? This one is 0, this one is 0, and means what is the L of y? L of y, this one. Substitute, and we claim that substitute u here, L of u is 0, and means u is a solution. It's okay, u is a solution, and L of v is 0. What does it mean? V is why there are differential equations, so v is a solution. So, and that is this one, that is u and v are solutions of the L of y is 0, our differential equation. So, and means what is the, and write y u plus iv, and this one is y is u plus iv, and u here is okay, v this one, it's okay. So what is the, and the u is, and here u is e to the lambda t cosine mu t, v is e to the lambda t sine mu t, are solutions and fundamental. Because what is the reason? Write the Wronski determinant, compute, and the homework is 1. It is easy to see that this determinant is equal mu e to the lambda t, and also we know that mu here, mu is non-zero. Mu is non-zero, and also exponential function is this one is 0, not 0, so this one is always non-zero. So non-zero means, Wronski determinant non-zero means u and v solutions, and these solutions also fundamental. It's okay. We know that u and v solutions, if Wronski not 0, so this solution fundamental. It's okay. So if we, and our differential equation is the second order differential equation, and we have two fundamental solutions, yes, we can write the general solution. What is the general solution? We know that general solution C1 times the first fundamental solution. What's the first fundamental solution here? This one is okay. E to the lambda t cosine, sorry, mu t plus C2 second solution this one, e to the lambda t sine mu t, and rewrite under this one is the common factor, so we obtain this one. Yes, it's okay. Any question? This one is the general solution of the our differential equation if our roots complex numbers. It's okay, complex conjugates. So if R and look at this one, R roots R1 and R2 is complex numbers, lambda plus and minus I mu, and so e to the lambda t and cosine mu t sine mu t. It's okay, this one, the general solution. So let's give one example, and then it will be better to okay. And so consider these example. For example, y double prime plus y prime plus 9.25, y is 0, y 0 is 2, y prime 0 is 8. And what can you say about this differential equation? This differential equation is the second order differential equation, yes, and also homogeneous because right hand side 0, and also the second order homogeneous differential equation. And look at the coefficients, it's okay, and the constants. So with constant coefficients, it's okay. So we know and how to solve this differential equation, but and this problem contains two initial conditions, it's okay. So initial value problem, this one. So how to solve the initial value problem? We know that initial value problem, every initial value problem has a unique solution. Because solve the initial value problem means solve first step, solve the differential equation. So we obtain infinitely many solutions and choose one of them, and satisfy the initial conditions. It's okay. So this one is second order differential equation. So and the characteristic roots has two roots, and we obtain two fundamental solution. So what's the general solution? General solution C1 y sub 1 plus C2 y sub 2. And this one gives infinitely many solutions, but choose one of them such that satisfy the initial condition. So means find the C1 and C2. It's okay? So, and we have two unknown. Our aim is to find C1 and C2, two unknown. And so we have to get and the two differential equation to get the unique solution. So, and the first initial condition gives the first the corresponding equation, and the second initial condition gives the second equation, and then we obtain one system, linear system, such that this system has two equation, two unknown. It's okay. So, and if our problem, initial value problem, if our differential equation, second order differential equation, means this problem has two initial conditions. It's okay. So, and let's solve this differential equation first step. It's okay. Let's solve find the general solution of the given differential equation. How to solve, how to find, right? And the design is homogeneous and constant coefficients. So write the characteristic equation, find the roots. It's okay. The corresponding characteristic equation, this one. So our aim is to find the solution. So rewrite this one, and 9.25 and 25 1 over 4 plus 9. It's okay. So we obtain this one. And so, and this part, and it gives r plus 1 over 2 square. And this one gives minus 9. So, and this square is minus 9. So, and we obtain r plus 1 is and I square minus 1. So, this one is minus and plus 3i square. It's okay. This one square is equal to this one. So, we obtain r plus 1 over 2 is plus and minus 3i. So we obtain complex roots. It's okay, but roots here complex conjugates. It's okay? And complex conjugate, because complex conjugates means A plus IB is roots. Complex conjugate is A minus B. It's okay? And plus and minus is complex conjugates. It's okay? This one are roots, complex numbers. So, and what's the form? Form is, we know that general solution of the and our differential equation e to the lambda t and times c1 cosine mu t plus c2 sine mu t. What's the lambda here? Lambda is minus 1 over 2 and mu is 3. Substitute here is okay. So we obtain the general solution this time. E to the minus 1 over 2t, c1 cosine 3t plus and so on, plus c2 sine 3t. It's okay? Any question about the solution of our differential equation? No question? Okay. So, but and our problem, initial value problem. Initial value problem means, and this one is the general solution. Our aim is to get unique solution. And so how to get unique solution? And also we claim that, but here, and the right is this one, y is C1 y sub 1 plus C2 y sub 2 general solution. But y sub 1 and y sub 2 should be fundamental, and the fundamental means, and the Wronskian should be not 0. It's okay? So let's see that. And the u, what's the, and here, sorry, and here we know that u is e to the minus t over 2 cosine 3t, and this one is the fundamental solutions. It's okay? So, and fundamental solution, u and v, u is the first fundamental solution, the second one v, and fundamental, compute the Wronskian determinant. We know that Wronskian determinant w uv is first row uv, and second row is the derivative of the first row. It's okay? And then write uv, u here, and v this one, and the derivative of this one is the product rule. We know product rule. This one is first one and second one. Derivative of the first one times second one, and first one times derivative of the second one. This one. It's okay? So we obtain u prime. It's okay? So, and v prime, and what's the v here? V this one, v prime, and use the product rule. Derivative of the first one times second one, and the first one times derivative of the second one. It's okay? So we obtain this one, this entry. So, and this determinant, 2 by 2 determinant, and we know when did this one multiply by and this one and this one minus this product. Yes. So we obtain this one, 3e to the minus t, this one. We know that this one is 1, so we obtain result. And this one is always non-zero because this one is exponential function. And then Wronskian, it is not 0, and means, yes, this one and this one fundamental solution. Yes, this one is the true, y is the general solution of our differential equation. It's okay? Because Wronskian not 0. So, and our aim here, find the unique solution of the initial value problem. And have to find y is this one is the general solution. General solution. So first, and the initial condition, this one. So you have to compute the y prime. Y is this one. Take the derivative with respect to t, and then this one is the product rule. It's okay. Derivative of the product is derivative of the first one times second one, and first one times derivative of the second one. It's okay? Product rule. So we obtain y prime, this one. It's okay. Any question here about this part? So what is the first initial condition? Let's come back our question. This one and also this one. It's okay, second. And the use and the first one and second initial conditions here. Y prime 0 is 8. And the substitute here. T is 0 and y prime is 8. Substitute here. And we obtain this equation. And second initial condition, y of 0 is 2, and take this one, substitute t is 0, y is 2 here. So we obtain C1 is 2, and the substitute here, we obtain value of C2. It's okay, C2, and then write the value of C1 and C2 in general solution here, substitute this one and this one. So we obtain y is e to the minus t over 2, and c1 is 2, c2 is 3, and we obtain unique solution of the initial value problem because has no constant here. It's okay. We obtain unique solution. Yes. Any question? No question. Okay. So let's give example. Find the solution of the initial value problem. This one is okay. And we have two initial conditions. We claim that this one is a solution. This one is homework. It's okay. And the next one, find the general solution of this one. First, identify this differential equation. So what's this differential equation? Second order, homogeneous because right hand side is 0. And constant coefficients, yes, 1 and 9. So, and second order with constant coefficients, homogeneous equation, this one. So, how to solve this one? Write the characteristic equation. Characteristic equation, r squared plus 9 is 0. It's okay. So, for r, so we obtain this one. It's okay. So, and lambda here, lambda is 0, mu is 3. It's okay. So, right here, y is the general solution, e to the lambda t, c1 cosine mu t plus c2 sine mu t. And lambda is 0, and substitute here, e to the 0 is 1, cosine 3t and sine 3t. It's okay, this one. So we obtain this one. Y is c1 cosine 3t plus c2 sine 3t. It's okay, the general solution. Any question about the solution? Okay. Let's solve the first one. Homework. It's okay. Let's consider the homework question. It's okay. Let's solve. How to solve this and the initial value problem. And this one is okay. But here, sorry, there's a typo, of course. Here, this one should be 0. It's okay. Should be 0. So, let's solve the first step, solve this differential equation and identify this differential equation first. One, homogeneous, it's okay, homogeneous, and also constant coefficients and also second order differential equation. So write the characteristic equation, find the roots. How to find the roots And the rewrite is this one. This one is not standard form. Standard form means, and this one is the coefficient should be 1, y double prime. It's okay. So, and write the standard form in the standard form, this one. It's okay. And we obtain this one. So, how to find the solution of the, how to find the characteristic equation, but I think, and the rewrite and this one, and then write the characteristic equation. So it will be practice, okay? So, and look at this one, this part is okay. Y double prime minus 1 over 2y prime is okay. And this one. So, and if we write here, it's okay. Plus and 1 over and this one, and so we obtain square root. It's okay, this one, and but I think plus 0 and minus 1 over this one, and also it's okay. So, and look at this part, and this part, and gives, yes, this part gives, and this one, it's okay. So we obtain this plus and this one. It's okay. Rewrite. Add to 0 left side plus 0, and plus 0 is this one. It's okay. So we obtain this one is y minus 1 over 4 square. So let's write the characteristic equation. And this one, we write in this one is r minus 1 over 4 square plus 9. This one is 9, is 0. 9 and minus 9 is okay. So this one is plus and minus 3i square. It's okay. So we obtain r 1 over 4 plus and minus 3i complex conjugates. It's okay. So, and here 1 over 4 lambda and mu is 3. So what's the general solution? E to the lambda t, 1 over 4, and cosine mu t and sine mu t. It's okay? So this one is the general solution. Okay? General solution of the R differential equation. And also, our problem is the initial condition, not enough to get the general solution. What is the, and here, we have two initial condition. Y of 0 is minus 2, y prime of 0 is 1. So you have to get y prime is y is this one, general solution. You have to compute y prime to use the initial condition. It's okay. So y prime, use the product rule. Derivative of the first one gives 1 over 4 e to the t over 4 times second one. And the first one times derivative of the second one, this one, is okay. C1 cosine 3t gives, and the cosine minus sign, minus, and we know that cosine u prime, you know from calculus 1, this one u prime minus sine u, cosine minus sine, and sine u prime sine cosine u. It's okay, this one. So write cosine 3t, u is 3t, and derivative of this one gives 3, and cosine is minus sine, minus yes, this one is there is a typo here. So, and this one, be careful. This one is cosine, and 3 times C1, this one is sine. sine 3t, and this one gives cosine. It's okay. So y of 0 is -2, and the substitute here y of 0 and write the t is 0. T is 0, this one is 1. Is cosine 0 is 1. And sine, and this one is 0, t 0. So we obtain c1. c1 is -2. Yes, this one is okay. And y prime, this one, write the this initial condition, t is 0, and then we obtain, and the value of c2 is okay. So we obtain this one. C1 is -2. C2 should be 1/2. It's okay. T is 0. Yes, there's a typo here because it is not possible to get the same solution. This one should be sine C1, and the derivative of this one sine t. Sine t. This one is cosine t, and the substitute t is 0. T is 0. So, and t is 0, and this one is 1. T is 0, this one is sun. C1 cosine 3t, and this one gives sine 0, t 0. This one is 0. This one gives 3t. It's okay. So is equal, and this one gives 1/4 is equal 1. So we obtain here 3/2. 3/2. 3 C2 is 3/2. We obtain C 1/2. Yes, these steps true. It's okay. C2 is, yes, but here this one should be sine. This one should be sine. This one cosine. There's a typo, but and the C2 it's true. It's okay. There's a typo here. So we obtain solution of the initial value problem. It's okay. This one. Any question about the solution? No question? Okay. So we obtain under this one, not homework, because our solution here is okay. This one. So, and the next case, if maybe our characteristic equation has repeated roots, it's okay, repeated roots. Now let's consider under this one, it's okay. Yes, take our characteristic equation. If our characteristic equation in this form, r minus r1 square is 0. So this one gives two roots, but repeated roots. Okay, it's okay. Multiplicity is 2. And so r1 is a root, and so this one, e to the r1t is a solution. But, and the second one, e to the r1t, same. Not the fundamental, not linearly independent. Wronskian is 0 if take the y sub 2 is this one. So Wronskian is 0. So, and not fundamental. So this one, it is not, and the second and solution of the our differential equation. It's okay. So what is the y sub 2 here? If r1 is the repeated roots, it's okay. So we claim that here it's okay. If repeated root, first one is this one, but second one, y sub 2 is v times y sub 1. It's okay. as a second solution, this one, and here, but what's the v here? But such that v here, v double prime is 0. It's okay? V double prime is 0. So V double prime is 0. What does it mean? V double prime is 0. Integrating both sides, V prime is and the constant, for example, A, and integrate both sides, V is obtained AT plus B. It's okay? V is a linear. It's this one. So, but here, actually, and take the A and B is constant, and take the B is 0, A is 1, and we obtain V is T. Take. It's okay? Here. So, our aim is to get the second solution, but second solution should be fundamental. It's okay, fundamental. We claim that, and this one, if this one is the first solution, and second solution should be y sub 2 is v y sub 1 such that v double prime is 0. Our aim is to get the what's the v. If we get v, and then we know when the y sub 2 is okay. So, and here, and we consider y sub 2 as a solution. Here v double prime is 0, so integrating both sides we obtain v is t. So what is the, and the y sub 2, substitute here, is okay. Y sub 2 is equal, yes, y sub 2 is equal v times y sub 1, v is t, t times y sub 1, y sub 1 is e to the r1t. So we claim that second solution is this one. It's okay, this one. So, and we claim that y sub 1 is e to the r1t, and then y sub 2 should be if and the repeated root multiplied by only t and gives the second solution. And also we claim that y sub 1 and y sub 2 fundamental. How to check that and these solutions fundamental? And you have to write the Wronskian determinant. Wronskian determinant W y sub 1 y sub 2 is equal y sub 1 e to the r1t, y sub 2 t times e to the r1t, and compute to this determinant. What is the determinant? Write the first row is y sub 1 y sub 2 e to the r1t, t e to the r1t, and the second row derivative of the first row e to the r1t, derivative of the, and this one, r1 times e to the r1t, and derivative of the t times this one, use the product rule, and derivative of the first one, 1, the second one, e to the r1t, plus first one times derivative of the second one, yes, and then r1 e to the r1t, that is this one. So, and use this one, so we obtain e to the r1t times e to the r1t plus t r1 e to the r1t minus t times r1 e to the 2 r1t. So, and this one and this one gives plus and minus. So, and this one. So we obtain only this part. Wronskian is e to the r1t. It's okay. So we know that, and always this one is non-zero. So yes, and y sub 2 and y sub 1 are fundamental solution. If fundamental solution, write the general solution. What's the general solution? C1 y sub 1 plus C2 y sub 2. So C1 e to the r1t plus C2 t times r1t. And this one is this one. It's okay. This is the general solution. Any question? Okay. Let's give an example to understand this one. It's okay. And here also color. And this method, the way to find the y sub 2, v times y sub 1 is okay. Whenever y sub 1 is a solution of our differential equation, this method is called the method of reduction of order. Reduction of order. If we have y sub 1, our aim is to obtain y sub 2, and if use this method, y sub 2 v times y sub 1, and find the v and write here. So this method is called reduction of order. It's okay? Reduction of order. So, and what is this method? And right, and we claim that this one is a solution. This one is a solution means our differential equation L of y is 0, and if y sub 2 is a solution and satisfy this one, and means L of y sub 2 should be 0. It's okay? And substitute here y sub 2, what's the v times y sub 1, and satisfy our differential equation right here. So this one should be 0. It's okay? Because y sub 2 is a solution. We claim that. It's okay? If y sub 2 is solution and satisfy our differential equation right here, this one should be 0. It's okay? So look at this differential equation. What can you say about the result differential equation? Look at this one, and this differential equation contains y double prime, y prime, and also coefficient of y double prime y sub 1. Coefficient of v prime is this one. There is no and v here, and no v. It's okay. V is so. And what can you say about this differential equation? This differential equation homogeneous, and also second order, but this one second order differential equation, but there is no and the term here v. Coefficient of v is 0 here. It's okay? So, and this differential equation is a not second order differential equation, and here, and this one transform into a linear first order differential equation, and also linear because there is no v here, v prime and so on. This one is not contained, and this one, and so, and linear, and also first order, a linear equation of order 1 for v prime, but v prime. Of course, look at this one. Identification, it is important for an differential equation. Look at this one. This one is second order homogeneous differential equation. Second order because highest derivative and the second one. It's okay, but look at this differential equation, and also coefficient of v is 0. It's okay. So, and this one, if some substitution v prime is okay, and for v prime, and the order is 1, a linear equation. Because what is the reason? Let's for example, v prime is w, right? Substitution, use this substitution. So we obtain, what's the v double prime? W prime, and so this one is transformed y sub 1 w prime plus 2y prime, and so on. W is 0. Look at this one. Yes, this one is a linear equation and of order 1. It's okay, first order, because and the w highest derivative is 1. It's okay. So, to understand this one, let's give an example. It's okay. It will be better. But I think let's have a break, and then we will consider some example. It's okay. Yeah. Any question about theory of and the method of reduction of order or repeated roots? Yes, no question. Let's have a break, and 10 minutes. I think it is enough.